Hi students, today we are going to discuss Coulomb's inverse square law in magnetism. Already do you remember we have studied Coulomb's inverse square law in electrostatics to calculate the force between two static charges. In the same lines now we want to get an expression to calculate the force of attraction or repulsion between two magnetic poles. Now here you can see two bar magnets. This is magnet A whose pole strengths at the two ends are QM-A and QM-A. So actually QM is also considered as a magnetic charge, but here it is called as pole strength. Since A is the given magnet, we use the subscript A. So we can see here QM-A represent the pole strength of the magnet A. Similarly, another bar magnet B is here on the right side, and it has two poles of equal strength QMB and QMB. So we have written QMB is the pole strength of the second magnet B. Now the distance of separation between the two end points, two end poles of these two magnets is denoted as R. R is the distance. So here the left side end pole is south and the right side end pole is north. So such poles are called as unlike poles. So they will attract each other with a magnetic force. So to calculate that force only, we want to use a law called Coulomb's inverse square law. Now, as per the statement of Coulomb's inverse square law, the attractive force here, in this case, the attractive force between the south pole and the north pole, let us take the force F. It is proportional to the product of the pole strengths. So the pole strength QM of the magnet A multiplied by the pole strength QM of the magnet B. This is the first part of the statement. So which says that the force of attraction or repulsion between any two magnetic poles will be directly proportional to the product of their pole strengths. And the second part of the statement says that it is also inversely proportional to the square of the distance between the two poles. That is why it is called inverse square law, because the square term is inversely proportional to the force. That is why it is also called as inverse square law. So the statement has 2 points. I combine these two and write F is proportional to QM A into QMB, the product of the pole strengths, divided by the distance square. Okay, this is the statement. Now, the left hand side is proportional to the right hand side. Therefore, I want to convert this into an equation. So I write, therefore, the force is equal to a proportionality constant K into QM A into QM B divided by R square. So I have written in scalar form. In vector form, if you write means this vector F vector is equal to K into QM A into QM B divided by R square into R cap, where R cap is the unit vector along the direction of R, that is from the south pole to the north pole. Okay, this is in the vector form also. Now, what is K here? K is called as what? K is a proportionality constant. Like this only we introduce proportionality constant. Though it is a proportionality constant, this factor K still depends on the medium between the two poles. So for example, if there is no medium between the south pole and the north pole, there is no medium, free space, vacuum. If there is no medium between these two, that is called as free space. Then what is the value of K for free space? For free space, that is vacuum, the value of K is found to be equal to a constant mu naught divided by 4 pi, and This value is in Henry per meter. So it's Henry per meter. Okay. So what is once again mu naught called as? Mu naught is a constant. Mu naught is also a constant. So this mu naught is called as absolute magnetic permeability. Absolute magnetic permeability. In electric field and electrostatics we have studied permittivity, is it not? That is epsilon naught. We have studied epsilon naught is called electric permittivity. Like that, this is magnetic permeability. Permeability means it is the ability of the medium to permit the flow of magnetism between the two poles. Okay, and its value, this value mu naught, value of mu naught is equal to 4 pi into 10 to the power of minus 7 Henry per meter. So if you substitute the value of mu naught here, K is equal to mu naught by 4 pi. So this 4 pi and 4 pi get cancelled, is it not? So the value of K will be for free space, K will be equal to 10 power minus 7 Henry per meter. Okay, so if you want here K is equal to mu naught divided by 4 pi. So this 4 pi get cancelled, the remaining is 10 to the power of minus 7 Henry per meter. Okay, suppose if the same two bar magnets are placed inside water, then the medium will be replaced, vacuum will be replaced by water, is it not? Or in air. Air is also another medium. Comparing to free space, air is also another medium. But in the presence of air and in the absence of air, there is not much difference between the force. Suppose if it is water or oil or inside the earth, you can bury the magnets, is it not? So the sand particles also will act as a medium. So I will write an expression for the medium. So in a given medium, then the force F is equal to mu naught into mu r divided by 4 pi, okay, 4 pi into QMA into QMB divided by r square. Now for free space, we have written, so this is mu naught by 4 pi into QMA into QMB by r square. Now mu naught is replaced by what? Mu naught into mu r. So this also can be written as what? Mu by 4 pi. Mu by 4 pi into QMA into QMB divided by r square. So here mu is the permeability of the medium, magnetic permeability of the given medium. I told you permeability is the ability of the medium to permit the flow of magnetic lines. Water and air and oil will not have the same capacity to allow the flow of magnetic lines between the poles. Is it not? Therefore, mu is the permeability of the given medium, and this also equal to what? Mu is also equal to mu naught into mu r, where mu r is equal to mu divided by mu naught. So this is a relative term which is called as relative permeability. Relative permeability. Now mu is also in Henry per meter only. The unit of mu naught as well as mu both will be Henry per meter. Therefore the relative term has no unit. Okay, so it has no unit. So this is called as what? Coulomb's inverse square law in magnetism. And you must be thorough with these expressions so that you can solve so many numerical problems in the board exam as well as the competitive exams. So once again, to summarize, my dear students, what is the statement of Coulomb's inverse law in magnetism? It states that the force of attraction or repulsion between any two magnetic poles, okay, is directly proportional to the product of their pole strengths and inversely proportional to the square of the distance between them. I hope you must have understood well. Fine.